You say you want even more trig identities? Well, here we go. So this is d, cos of x plus y times cos of x minus y equals cos squared x minus sine squared y. So we're going to use the sum and difference formulas for cos. So looking at this one as x plus y, so we're going to end up with a minus, so it's cos x, cos y, minus sine x, sine y. And this one's a minus, so that's where we have the plus, and these laws will be on your exam, like given to you. So then cos of x minus y ends up being cos x, cos y plus sine x, sine y. Now, using all colored arrows, I'm going to expand. So cos x, cos y times cos x, cos y gives me cos squared x, cos squared y. Following the red line, cos x, cos y times sine x, sine y will give me all of them. So sine x, cos x, sine y, cos y, and it's add. Following the green arrow, it's a minus sine x, sine y multiplied by cos x, cos y. So that makes our green down here. And lastly, following the orange arrow, the minus makes it a minus, and then sine x times sine x and sine y times sine y. So sine squared x, sine squared y. These middle terms are exactly the same, so one's plus and one's negative, so they go away. And then I'm left with cos squared x, cos squared y, minus sine squared x, sine squared y, which is more than what I want, because I eventually want to get over here, so I need to follow the next page. Looking at this, I decided to replace cos squared y with 1 minus sine squared y. And then I expanded that, so cos squared x times 1 is cos squared x. Cos squared x times minus sine squared y is cos squared x sine squared y. And then I still have the minus sine squared x sine squared y at the end. In my next line, I decided that I would look at the sine squared x here and replace it with 1 minus cos squared x. And then again, I'm going to end up expanding. So cos squared x minus cos squared x sine squared y was what we had. This sine squared y multiplies by 1 to give this minus sine squared y. And this sine squared y times cos squared y, or cos squared x, gives me this. And it's a plus because this minus and this minus make a plus. So in this line, you'll notice that we have a minus cos squared x and sine squared y, and we have a plus cos squared x sine squared y. So those will go away. And I'm left with cos squared x and minus sine squared y. And that's the right side. That's what I wanted. This one looks like it was going to give me trouble, but I started with the left side, and I noticed that they had a common factor of cos x and 2, as a matter of fact, and I pulled those out front. So then 2 cos x divided by 2 cos x is 1. Minus 2 cos cubed x divided by 2 cos x is minus cos squared x. I know from the Pythagorean identities that 1 minus cos squared x is actually sine squared x, so I replaced it. So on the left side, I have 2 cos x sine squared x. On the right side, I have a sine x, but I have a sine 2x. I have no cos, so I have to figure out what I'm going to do. I know that sine 2x comes out to be 2 sine x cos x. So what I end up with is sine x, or 2 sine x, sine squared x cos x, which is exactly what I had on the left side. Done. Well, this is the last trig identity I think I'm going to do tonight, and then I got to work on some other stuff. This one is cotan theta plus tan theta, and like I've done in class, I always have, I change things to sine and cosine. So cotan theta is cos theta over sine theta. Tan theta is sine theta over cos theta. I get a common denominator of sine theta times cos theta. In order to do that, I have to multiply sine theta by cos theta, which means I multiply the top by cos theta, getting a cos squared theta. Similarly, on this side, I have the cos theta. I need to multiply it by sine theta, which means I multiply the top by sine theta to get sine squared. The Pythagorean identity is right here on top. Cos squared plus sine squared, that's 1. So I end up with 1 over sine theta cos theta. This is nice and simple looking, so I think I'll work the right side. The right side says 2 cosecant 2 theta, so that's the same as 2 times 1 over sine 2 theta. And then I can sine 2 theta then is equal to 2 sine theta cos theta from our formula sheet. And then these two cancel, and I end up with 1 over sine theta cos theta, which is the same as the left side. Have a good night. Good luck studying.